Good morning, guys. This is your video for today. We're going to talk about a couple different things. First off, your quiz is on Infinite Campus or in Infinite Campus and graded. So you can get on there and look at your grades. If you have specific questions, if you want to know which ones you missed, you can just email me and let me know you want to know that, and I can let you know kind of where you were off and what points you missed. The biggest thing I've seen from the quizzes is a couple problems. Some people just put answers and didn't kind of show me the process that they took to get to their answer. So I was pretty lenient on that this time. So you'll see the scores are mostly pretty good. Next time I won't be so forgiving. I need to see the process. If it's a quiz, I need to see the process that you're taking to arrive at your answer. Because there's a million different ways you can get that single answer. A lot of different resources you can just type in and get an answer. But I want to see that you understand how to get to that and the process that it takes. Now, if you want to redo the questions you missed, you can definitely do that. Again, just shoot me an email on those, and I'll send you the ones you missed. You can redo those, talk about those, resubmit those, and you'll get those points back. So the second thing is we are not going to have live streams anymore. The last live stream on YouTube was just technically there's so much that went wrong. And for your alls, it wasn't even that bad. The Algebra 2 class before you all was a mess. And for some reason, the program on my iPad doesn't work that well when it live streams. Now, for these videos, it works perfectly. So I don't know. So for right now, the live streams are going to be gone. And anytime we need a lesson covered in a video, it will just be posted. So you don't actually have to be there in a live stream. But there is going to be something you have to do to kind of prove that you watched the video and also get your points for engaging in that video. And we'll talk about that at the main end of this video after we get through the content in Lesson 5.5. But the last thing we'll talk about, and then we'll jump right into the content, is that we are going to have probably once a week meetings through either Google Meets or Zoom. So a way for us all to connect live in person all together to be able to have some discussions, ask questions, just basic, just to make sure everybody's on the same page, make sure we know scheduling and things like that. So be looking for information on that later in the week on Google Classroom. And like I said, that'll either be through Zoom or Google Meets. I'm pretty sure Google Meets, you'll have to download the app. I think you can join a Zoom meeting without the app, but it works better with it. So I think either one you'll have to download a single app, or you can also do both of those through the computer. So I'll put out that information later. So where we are moving to today is Lesson 5.4 in your book. So this section is all about using those trig functions and those trig ratios to find the measures of the sides of a right triangle. Okay, so that's going to be our whole focus in every example that you'll see in this target in this section in your book. It's focused on using the trig functions to find side lengths. Okay, so we will jump right in and talk about a couple of these examples just to really quickly kind of run through those. Like if you look at example 1, it gives you something like this. Gives you a right triangle, it fills in angle P, which is 35 degrees, and it gives you side R, which is 14. And what it's asking you to do over here is find Q. So basically your thought process when using these, because when it gives you that reference angle, the angle that you're going to use to apply the trig function or whichever ratio you think applies, you have to think about if you're using this angle, which is 35 right here, and this side, which is 14. Well, obviously, if you're thinking about is that side opposite, adjacent, or is it the hypotenuse? Okay, well, that side, the 14, is the hypotenuse because it's opposite the right angle. Okay, so hypotenuse. So we know we have to use either sine or cosine because both of those include the hypotenuse. But then it's asking you to find the value of Q. So we're wanting to find Q, so we need to think about, okay, well, what relationship does that have with angle 35? Well, it's right beside it, so it's adjacent. So we're going to have to use the trigonometric ratio of adjacent over hypotenuse, which hopefully we know by now is cosine. So the difference on these problems is we have the angle. So we're not finding like cosine of theta, and we're just saying a generic angle, and we're throwing out ratios. We're actually finding, okay, cosine of 35 degrees is equal to the adjacent side, which is Q, over the hypotenuse, which is 14. So now what we have is we have the cosine value that we can tangibly find. We can find the cosine of 35 degrees. And then we have one single variable on the other side that we can find as well. So we would solve this just like we would solve any other equation. We would multiply the right side by 14 to get q by itself. Then we would multiply the left side by 14. So essentially all we're doing is 14 multiplied by the cosine of 35 degrees. Now, you can use a scientific calculator if you have it. I'm not for sure if iPhones and smartphones will do trig functions. That's something to check on. But I know also you can go to Desmos. So desmos.com/calculator on a computer, or you can download the app. All those will allow you to type in those trig functions very easily and to do a calculation like this very quickly and very easily. Now, you have to make sure whether it's a scientific calculator or Desmos or whatever, that it's in degrees. Most calculators will default in radians mode. So you have to go to settings on the calculator. You can Google that if you need to find out what calculator you have and how to change it. But on Desmos, I think there's a settings tab on the top right. You switch it over, type that in degree mode, 14 multiplied by the cosine of 35 degrees, and it's going to give you some big long decimal, which is like 11.46812, and so forth, so forth. All right. So for our purposes, if it doesn't say either do it to the 10th or the 100th, one or two decimal places, we would just say Q is 11.5 or 11.47 on this problem. Either one would work when we are assigned our problems and doing what we're doing. Okay, so moving to the second example that it gives you in your book is it gives you something like this right here. It gives you a little, it says it's a tent, and the R there is a rope attached to the tent. So it's the same type of problem. What we're given is one angle and one side. And then it's asking us to find, eventually, I think in both of the sections on example 2, R and D. So it's all about, again, thinking about the angle that you're given, and in reference to that angle, which trig ratio you want to use to be able to get just one variable, right? If we're looking at this angle here, which you notice it's in the degrees, minutes, seconds, we would have to convert that. So if we were kind of working through this problem, the first thing you might want to do is make sure you know that 52 degrees in 15 minutes is the same thing as 52.25 degrees. Now we get that by just taking this 15 minutes and dividing it by 60 because of the ratio and the relationship between how many minutes are in a degree and all that. Okay. So we get 52.25 degrees. Now, we couldn't use cosine right off the bat because cosine is adjacent over hypotenuse. That would be D over R. Well, we can't have two variables or two unknowns, so we would need to start out by using sine. Sine is opposite over hypotenuse, so we would take the sine. If we were trying to find R, which is the length of the rope, so in order to find the rope, we would take sine of the 52.25 degrees, which is the converted. So again, it comes back to some of the stuff we did in the first 3 sections, knowing how to convert between DMS form and then just standard degree form. And that's going to be equal to opposite, which if we think about where this angle is to start, opposite is the 40 over hypotenuse. Hypotenuse is R. So if you look at this one, you should notice that it's a little bit different than the first example because this time we have the variable in the denominator. Last problem when we set up our ratio, we had x over 14 and we just multiplied by 14. Well, this time we can't just multiply by 40, right? Because the 40 is in our numerator. So if I'm going to solve this one, I'm going to multiply both sides by r. And I'm going to get r multiplied by the sine of 52.25 degrees equals 40. Then if I want to solve for r, I have to divide that sine value out. So r is going to end up equaling 40 divided by, instead of multiplied by this time, the sine of that 52.25 degrees. Okay, so this time we actually ended up dividing it because of the placement of the variable. So hopefully you've seen problems like this before and you're at least somewhat familiar with them. but just make sure you pay attention to the position of the variable and knowing, well, I'm going to multiply the sine of 52.25 degrees by 40, or am I going to divide 40 by that? And it, again, depends on that variable placement. Okay? Then the third example there, and we're not going to do the whole thing, because, again, you can go through this example in your book. It's on page 300. Is I want to touch on one thing. It mentions a couple terms in here that's a review of some geometry terms. Like it mentions the term apothem. Apothem, you basically just have to think it is center to midpoint. So it's center of the circle to the midpoint of one of the sides of the inscribed shape or the inscribed polygon that is inside of the circle. So the apothem is labeled there by A. Let me put the apothem in red here. The apothem is the dashed line because it's from the center point of the circle to the midpoint here of one of the sides of the inscribed polygon. So that's what it means by apothem. Then as far as the other parts of it, the only thing I want to mention on this problem is it just kind of assumes you're understanding where the degree measure comes from. So we're wanting to know what this measure is so we can apply either sine, cosine, or tangent to be able to find the value that we're looking to find, which is the apothem there, the dashed line. So it tells you to do 360 divided by 10, and that would give you 36, and that this angle is 36 degrees. What you have to think about is, why did they divide by 10? Well, in this case, you can form these triangles by going point to point on the pentagon, right? This triangle was this point here, down there, to this point here, right there. So, can't really see that when I put the dots. So here to here is one triangle, right? So another triangle would be here up to there. So that'd be another one. Then I could draw another one that's there to there. Another one there to there. And then you have another one. So you basically end up having 5 triangles. Well, if you were wanting to know just what's one of the angles right here, you would just do 360 divided by 5. But then you look at this angle in the purple triangle, that's cut in half. So you could either divide it by 5, then divide it by 2, or just divide it by 10 right off the bat to get that angle measured. Now, say this was a hexagon. It could consist of 6 interior triangles. So you would divide it by 12 to get that half measure of one of the triangles. And same thing with like octagon. If it was an octagon, there's 8, so you would divide it by 16. So just kind of knowing how that relationship works, it's always 360 because they're inscribed in a circle. And then for this one, you divide it by 10. So that's where that 36 degrees comes from. And then from there, you just reference that 36 and think about, okay, I need to find A, which is the dashed line. It's given me 4.17 as the radius, or the radius of the circle, which is the hypotenuse of the right triangle. So you need to do A, which is adjacent to 36, over 4.17, which is the hypotenuse. So you're doing adjacent over hypotenuse, so you take the cosine. Okay? So it's just applying those trig functions, again, to use the angle that you have and apply it to one of the known side lengths to be able to find the side length that you don't know or you're wanting to find. Okay? So then where we are going to kind of finish up is the problems that you should have maybe tried on your own if you had a chance to today, which is the check your understanding problems on 301 and 302. Most of the first ones are pretty basic, but we're going to focus on numbers 8 and 9. Okay? On number 8, it says that each base angle of an isosceles triangle measures 55 degrees in 30 minutes. Each of the congruent sides is 10 centimeters long. So it tells you that we have an isosceles triangle, which means these two sides are the same, these two angles are the same, and it tells us what they are. It tells us that the side lengths are 10, and the angle measurements are 55 degrees in 30 minutes. Now, 30 minutes should be an easy one to convert because 30 out of 60 is half, so that means each angle is 55.5 degrees. Okay? Then the question is to find the altitude. Well, altitude is obviously just the height, so we're finding this value right here. Okay, that would be the altitude, which is creating a right triangle on both sides of that. So again, all we're doing is thinking about which trig function would apply to be able to find the altitude or the height, which I'm just going to put here as x. Well, we're going to use 55. X is opposite of 55, so we're going to use opposite, and we know 10 is the hypotenuse. So on this one, we are going to use sine. And we would set it up by saying sine of 55.5 degrees equals opposite, which is the x, the unknown, over hypotenuse, which is the 10. And again, we multiply by 10. 10 times the sine of 55.5 degrees, you get that value. Okay? So again, you can type that into a scientific calculator, Desmos, or whatever you have. It gives you a big long decimal, and you can round it to 1 or 2 decimal places. That doesn't matter as far as which one you round. Then the next part of the problem asks you to find the base. Well, the base down here of the triangle is the full length, but it's made up of 2 individual equal parts of these 2 right triangles we created. So we need to find one of these and then just double it. And if I was wanting to find y, I would still use that angle of 55.5 degrees, but instead of using sine, I would use cosine. And cosine of the 55.5 would be y over 10. And then you, again, just multiply by 10, put that function in your calculator, get that, and then the last one tells you to find the area, which is just 1/2 of those 2 values multiplied on A and B. Okay? So again, it's starting to contextualize these concepts and put them in the context of actually solving problems that are given based on setting up these triangles and seeing them in different scenarios in different ways, but applying these trig functions to help find the missing side measures of these right triangles that we're going to have. Then the last problem that we're going to do on here is number 9 on page 302. Check your understanding. On number 9, and this is my wonderful drawing here, it tells us that there's a lighthouse in Florida and that it is 175 foot above sea level, and there's a boat. So there's the boat, and it's giving you the angle of depression from the top of the lighthouse to the boat, which it tells you the angle of depression is 13 degrees and 15 minutes. Like we just said, 15 minutes is just 15 over 60, which is 0.25. So the degree of, or the angle of depression is 13.25 degrees. So now, earlier in your book, it talks about angles of depression and angles of elevation. So you have to kind of know which one's which and how it's going to be constructed. So first off, it tells you that it's a angle of depression from the top of the lighthouse to the boat. So that's kind of the distance it's talking about. But the angle of depression starts at the top and is opening up towards the bottom. So what most people tend to do is they want to draw the right triangle here and then put there and then put the 13.25 up there. But that doesn't work because that's not opening down to the boat. That's the boat kind of opening up towards the lighthouse. Another way you can think of it is angles of elevation and angles of depression are always formed by the diagonal connected with a horizontal line. So for the angle of depression, it's actually going to be up here. It's going to be right here. Okay, so we know that angle right there is 13.25 degrees. Now, if I was looking at the angle of elevation, it would be starting down here at the boat and opening up towards the lighthouse. Okay, so that's kind of how you have to think about that when you're thinking of, is it an angle of elevation or depression, and where do I put the actual value that it gives you? So the 13.25 goes there, and then what it tells us is this lighthouse is 175 feet above sea level, or above where the sea is. So what we need to find is one of these other angles. So you can do it a couple different ways. You can kind of mirror the 13.25 down by the boat if you're looking at like 2 parallel lines intersected by a transversal. You can also think, okay, this is 13.25 here. So this is a 90-degree angle. So this one has to be complementary to 13.25. So that one would have to be 76.75 degrees. Okay? Then once you know that, you have an angle, you have a side length. And what you're trying to find is this value down here, because you're wanting to find the distance between the boat and the shore, basically. Okay? And you would need to find, this time you don't have the hypotenuse, you have both of the other sides, the legs. So that's going to be the tangent function, because that one, tangent, does not include hypotenuse. So for this one, if we were doing it this way, we'd take tangent of 76.75 degrees. And we would set that equal to opposite over adjacent. Opposite of 76.75 is x. The adjacent side is 175. So the value that you're looking for, the distance from the boat to the shore, is going to be equal to 175 multiplied by the tangent of 76.75 degrees. And again, put that in your calculator, get that, round that to the nearest tenth or hundredth, unless it specifically says another place value to round it to. Okay. So other than that, I'm going to hold off on example 4 to later, and then you'll get your assignment as is. So we're at about 21, 22 minutes right now. So I'm going to go ahead and kind of finish up what we were talking about earlier. And if you run into any problems with the assignment that you have today, just shoot me an email. The emails may be a little delayed. Some of them I get, but it's not till like 20, 30 minutes after. If you send me a message on Google Classroom, it will give me a notification on my phone instantly. So that's going to probably be the best way to get a response from me the quickest. But I check my emails too. If I see it, it just doesn't pop up as a notification on my phone. So if you're wanting the best way, it's probably Google Classroom. So if you have questions about your assignment, definitely just get that to me through any form of communication. Okay. So the last thing is what I was talking about earlier. Since there are no live streams now, you're interacting with the video, you have to prove basically that you watched it, prove that you are pulling it up and you're interacting. So you need to have a YouTube account, because you're going to have to make a comment on this video. Okay. If you don't have a YouTube account, it's really quick and really simple and easy to sign up for one. You can even use your school email account if you just want to create a generic one to make comments on here. So on your comment, you need to first put your name, just simply because everybody's YouTube handle may not be recognizable to a specific person. So just put your name, and then you have to do one of two things. You either have to make an observation about the video, so something that you learned, something that you noticed, something that you benefited from, or just some sort of observation. Or ask a question, something that's still kind of up in the air about the section in your book that wasn't covered in the video, or something that was covered in the video that you really didn't understand why we did something, or when we did that, why did we get this? Just a specific question. Then I'll either reach out to specific people about those questions, or if we have a pool of, say, 8, 9, 10 people asking the same thing, then obviously we'll follow up through that, either through another video or some sort of form where we have an example similar to that to clarify, or something. But you have to comment on the video, either an observation or a question. Okay? So name, observation, and or question. That's how you get your participation credit for the videos that I post on YouTube for our class. So, as always, this video is linked in our Google Classroom page. So if you want to reference it, it is there, but it will also just be up on this channel that I created for pretty much however long you need it. So make sure you do that. Start with this video. This video, you need to make a comment that either has a question and or an observation. Okay? So don't forget to do that. Be looking for the information to be sent out on the virtual meetings, class meetings that we're going to have. I'll probably send information about that before Friday or by Friday, and then we'll look to have our first one of those next week. So if you have questions, let me know. Other than that, that is it. So we'll see you guys next time.